Alright, this is Go Magic, we're learning physics together, it's magical. Now we're talking about conservation laws. The three collisions you need to know. What is of collisions? We have the elastic collision, the inelastic collision, and the completely inelastic collision. Also known as the fuse collision. So, conservation laws. When there are three types of collisions, what is conserved? Most important thing, when you're talking about momentum, conservation of momentum. In previous video, this is known as POCOM, Principle of Conservation of Momentum. It is conserved in all collisions. Okay? Conserve elastic, inelastic, completely elastic fuse collisions. Okay? Just in case you know what collisions are, it's when two objects collide with each other. This is one example of two objects colliding with each other. And how do we know it is different type? 100% we can use momentum. Why? Momentum, all three. POCOM is conserved in all three. So you cannot use it to actually differentiate between the three collisions. The next conservation you should know, I call it POCOM, Principle of Conservation of Total Energy. Total energy. Similar to momentum, it's conserved in elastic, inelastic, completely inelastic collisions. So it's always conserved. So we can use POCOM to differentiate between three collisions. We cannot use POCOM to differentiate between three collisions. So which one can we use to actually differentiate? One more, which is POCOM. Which is Principle of Conservation of Kinetic Energy. Okay, kinetic energy, only one is conserved, which is the elastic collision. And when it comes to inelastic collisions, both this is inelastic. They are not conserved at all. So when questions are asked, usually they'll be involved in asking you, how do you know it's elastic or inelastic? Easy. Notice here. When it comes to kinetic energy, it is not conserved here. Okay? So, what does this actually mean? It just means one very important thing. When it comes to kinetic energy, it's conserved. What does conserve means? It means that the sum of the kinetic energy before is equal to the sum of your kinetic energy after. Means all the kinetic energy initially is equal to the kinetic energy finally. Means there is no loss of kinetic energy. Okay? When you look at conservation, POCOM, you can think of there's no loss of kinetic energy. Okay? So there is no loss and decay. When it comes to inelastic collisions, there is a loss of kinetic energy. Why? If you think about in real cases, what really happens in a collision? You hear something? Yes, you hear the sound of collision. Will there be a temperature increase? Probably will be. That's why in these two collisions, what is inelastic, it just states that there is a loss in kinetic energy. So what is it lost? So the EK before will be converted into EK after. In this case, plus sound energy plus heat energy. What about fuse collisions? What does fuse collisions mean? It means that there is collision between two objects, and what you result in is one huge fuse object moving in a particular direction. Okay? Here you still have, for example, colliding. You still have two objects moving. Okay, this is example. There are a lot of examples of collisions. But in this one, you have a completely new object. What happens there? EK before. Yes, majority is still EK after. But there's another major energy change, which is the deformation energy. So energy used for deformation. And then after that, plus your heat and sound. Okay, I'm going a bit deeper in this case, just to allow you to understand what exactly is happening. Elastic means no loss of kinetic energy. There is a loss here. Realistic case, there is a loss. What is it lost in? Don't worry, there's no equation for sound and heat energy. You just have to know that is loss in EK, there is loss in K. Okay? In this case, just remember, there will be a loss in kinetic energy. So you're going to check whether it's elastic or inelastic, only use Pocock. When you want to look for their velocities for elastic collisions, fused collisions, you can use Pocock to find the velocity, because this conserved means velocity will still be maintained quite nicely. So I hope you understand this video. There's going to be a few questions related to this. Feel free to come back to this video again, and as more questions do, then realize, oh, okay, I just need to remember 3 collisions. Pocock is very important. Pocock is very important for any sort of velocity you need to find.